So the first topic that we're going to look at, CC1, is called states of matter, and I have drawn out the three states of matter. I've drawn the particles in a solid, the particles in a liquid, and the particles in a gas. You need to know how the particles are arranged in each of the three states, and you need to know how the particles behave. So in terms of arrangement of particles in a solid, they are tightly packed and in neat rows. In a liquid, they're still touching, but the arrangement is random. And in a gas, they are far apart. And again, the arrangement is random. I've included this information for you in your core info guide. So solid, liquid, and gas. The arrangement of the particles is here. And then movement of the particles is in the row beneath. So in a solid, the particles can vibrate. In a liquid, they move around each other. And in a gas, they move quickly in all directions. This table also tells you that the particles in a gas have the most energy and the particles in a solid have the lowest energy. Okay, you need to know the information in this table, which is on page 2 of your core info guide. You can move from one state to another, and these are called state changes. So if I want to go from a solid to a liquid, that is a state change. And it is called melting. Okay, and we know if you want to go from ice to water, you melt it. Okay, so it's called melting. If I wanted to go from liquid water to water vapor or to steam, I would need to boil. So I can write boiling or I can write evaporating. Okay, and melting and boiling involve heat. So you have to put heat in to melt something. You have to heat something to boil it. Okay, if I want to go the opposite way, from a gas back to a liquid, then I need to do the opposite of heating. So I need to cool it. And this state change from gas to liquid is called condensing. Okay, similarly, I can go from a liquid back to a solid. Again, to go back this way, I would need to cool. And in this case, the state change is called freezing. So if we're going this way, I am heating. And if I'm going back this way, I am cooling. And these changes are called state changes. Okay, again, this information is here for you in your core info guide, all of the names of the state changes. State changes, okay, are example of physical changes. Okay, so there are two different types of changes in chemistry. There are physical changes and there are chemical changes. Chemical changes refer to the changes that occur in a chemical reaction, and they are hard to reverse. So for example, a chemical reaction, if I took sodium, which is a metal, and I reacted it with chlorine, which is a green gas, if I reacted those two together, I would form sodium chloride, which is the table salt that you would put on your chips. Okay, so I'm taking a very reactive metal, I'm taking this poisonous gas, I'm reacting them together, and I'm making sodium chloride, which is salt that you could put on your chips. All right, I have made a new substance, so it's an example of a chemical change. So table salt is new, it's different from what I started with. And this is very difficult to reverse. If I gave you normal table salt and asked you to get the sodium metal back or to get the chlorine gas back, that's going to be very difficult. So this is an example of a chemical change. The opposite of a chemical change is a physical change. Okay, chemical changes are hard to reverse, but physical changes are easy to reverse. In a chemical change, a new substance is made. In a physical change, no new substance is made. And when we look at state changes, we will see that they are examples of physical changes. Okay, they are easy to reverse. If I go from a solid to a liquid by melting it, I can easily go from the liquid back to the solid by freezing. So if I have ice and I melt it to form water, I can easily turn it back into ice again by just popping it in the freezer. So these changes are really easy to reverse and no new substance is made. So if I have got solid ice and I melt it, I've still got liquid water. Okay, it would be H2O as a solid, it would still be H2O as a liquid, and as a gas, as steam, it's still H2O. I'm not making anything new, I'm just changing it from a solid to a liquid to a gas. Okay, so state changes are physical changes because they are easy to reverse and no new substance is made. What I want you to do is I want you to learn that information, okay? I want you to learn the information in this table on page 2. Okay, so learn this information on page 2. Learn your state changes, know what they are called. And when you feel confident that you know that information off by heart and you know this information, then answer these 4 questions. So try and answer these 4 questions without using your notes. Learn the information, answer the questions. Okay, I want you to press pause as you do this. And when you have learned the information and answered the questions, press play to check that your answers are correct. So press pause, learn, answer the questions, and press play when you're ready to check your answers. Okay, so I've filled in the answers. Okay, for number 1, you can write evaporating or you can write boiling. That's the state change from a liquid to a gas. Okay, know the names of all of your state changes. Describe the movement of particles in a solid. Okay, if I look back at my table, I'll see in a solid that these particles can only vibrate. In which state do particles have the most energy? In a gas. Okay, the particles in a gas can move the most. They've got the most energy. And describe why state changes are physical changes. Because they are easy to reverse and no new substance is formed or no new substance is made. Okay, so that is CC1, that is states of matter. So we're now going to look at CC2, which is separating mixtures, and I'm on page 5 of your revision guide. On this page, you will see the 4 different techniques that you need to know to separate a mixture. The first technique is filtration. You would use filtration to separate an insoluble solid from a liquid. And by insoluble, I mean does not dissolve. So an example would be sand and water. Sand doesn't dissolve in water, so if you pass it through this filter, the sand will be trapped in the filter paper, the water will all pass through. Okay, a common everyday example would be having pasta and water, and you pass it through your strainer. The pasta gets trapped in the filter, the water passes through. And you can use this technique for any solid that does not dissolve in a liquid. You pass it through a filter, the liquid will pass through, the solid remains trapped, and it is called filtration. Okay, you've got another technique called crystallization, and this one we use for soluble solids from a liquid. And by soluble, I mean it does dissolve. So an example of this would be salt and water. Okay, if you have salt in water, the salt dissolves. Okay, you can't see the salt, it dissolves. And if you took your salt and water, and passed it through the filter, the salt would stay with the water and would just pass straight through. So you need a different technique called crystallization to separate a solid that does dissolve in a liquid. And what you will do is you will heat your salt and water, for example. I'm going to heat using a Bunsen burner. And when I heat my salt and water, my water is going to evaporate. Okay, so I'm going to write water evaporates. So we've just seen our state changes. We know if we heat liquids, they will turn into gases, and that state change is called evaporation. So we heat our salt and water, the water will evaporate, and you'll just be left with your salt. So that technique is called crystallization. You heat the water evaporates, you're just left with your salt. The problem, however, with this technique is that you lose all of your water. Okay, it evaporates, it spreads off out into the atmosphere, into the room, and you lose your water. So what if you had salt and water and you actually wanted to keep the water? So just say you are trying to get water from seawater. Okay, you all hopefully know that seawater is salty. You want to separate the salt from the water, but you want to keep the water. In this case, you would use simple distillation instead of crystallization. So crystallization, that water escapes. Simple distillation, you manage to hold on to the water. Okay, we're going to look at what happens in simple distillation. You would put the salt and the water in, you would put the salt and water here into your distillation flask, and you would heat the salt and the water. Now, just like what we saw with crystallization, when you heat salt and water, your water is going to evaporate. Your water will turn into a gas. So I'm going to write here that the water evaporates. But instead of that water vapor being able to escape out into the atmosphere, you'll see that in simple distillation, that water vapor is trapped. So that water vapor will rise up here, okay? All of your water vapor, your water as a gas, will rise up here. And when it gets into this part, which is called the condenser, the water vapor cools down. And when the water vapor cools down, it condenses and turns back into a liquid. So I'm going to write water vapor is cooled, then it condenses and turns back to a liquid. Okay, so you heat the water, you turn it into a gas. That hot gas rises up here and enters what we call the condenser. The condenser is cold, and when you cool that hot gas, it will turn from a gas back into a liquid. You can then collect that liquid, and that liquid will be pure water. Remember, the salt doesn't change state at all. The salt just stays here in this flask. The water evaporates, then cools and condenses, and you can collect the pure water. And that is called distillation. Just want to draw your attention to the condenser itself. You need to keep the condenser really, really cold. And to do that, you connect the condenser to a tap and you put cold water in at the bottom and let that cold water flow out at the top. I want you to highlight that, okay? That the cold water is going in at the bottom and the cold water comes out at the top. And the purpose of that cold water is to keep your condenser cold so that your water vapor will be turned back into a liquid, okay? That's simple distillation. The last technique is chromatography. We use chromatography to separate the different compounds in ink. Okay, so you would have done this in year 7 and probably in year 9 as well. You take your pens, you put a spot of ink on a piece of paper, you put that piece of paper into a solvent such as water, and the different colours in ink will separate out. And this technique is called chromatography, and you're going to use it to separate the different colours that you have got in ink. Okay, so in your guide, I've got some key questions which refer to chromatography. But underneath your key questions, I've got practice questions, and these are the ones I want you to do now. So I want you to answer these 3 questions. So what temperature would the thermometer show? So here's your thermometer. Remember, you're doing this technique with water. So what they're asking you is what temperature does water boil at? Okay. They want to know the function of the piece of apparatus labeled R. So this piece of apparatus here, what is the point of it? What does it do? And they want to know the name of this whole process. So that's questions 1, 2, and 3. And then for me, I also want you to answer question 4, which is what state change is occurring here in this flask. And question 5, what state change occurs here in the condenser. So press pause, answer those 5 questions, and press play when you are ready to see the answers. Okay, so I've filled in the answer. What temperature would the thermometer show? Okay, if you're boiling water, then that thermometer is going to show you a temperature of 100 degrees Celsius because that's the temperature that water boils at. Okay, what is the function of the piece of apparatus labelled R? The piece of apparatus labelled R is called a condenser, and the function of a condenser is to cool the gas and turn it back to a liquid. Okay, so we've got water that's turned into a gas. The gas enters the condenser, and the condenser cools that gas and turns it back into liquid water. So the function of the condenser is to cool the gas and turn it back to a liquid. Okay, and please take note that to keep the condenser cold, we put cold water from the tap, goes in at the bottom, and that cold water from the tap comes out at the top. So water goes in at the bottom and it comes out at the top. It keeps the condenser nice and cold. This whole process is called distillation. I wanted to know what state change occurs here. Okay, so here we are heating water. So the state change that occurs is evaporation. The liquid water evaporates and turns into a gas. It doesn't specify here what is heating my flask. It could be a Bunsen burner, or it could be a hot plate, okay? So there's a few different ways to heat something in a lab. A Bunsen burner is a common one, but another way of heating something in the lab is by using a hot plate, okay? What state changes occurs here in 5? In 5, you've got condensation. So that hot gas hits the cold condenser and it goes from a gas back to a liquid. That is called condensation. Okay, so this is CC1 and CC2, states of matter and separating mixtures. There are a few more practice questions in your guide that you can also answer for yourself, and all of the answers are included at the end.